Hi guys, welcome to our first Saturday session of the new academic year with ExamRevision. My name is Anya and I'm going to be taking you through some maths content today. And please do check out our social media accounts over the coming weeks for all of the information about our various Saturday sessions that will be taking place every Saturday here on YouTube. And today, as I said, I'm going to be focusing on maths. And what I'm going to do to kickstart our Saturday sessions for this year is I'm going to do an algebra recap of all of the main topics that you guys should know going into your Leaving Cert from maths, both for ordinary level and higher level students. So what I'll do is I'll be going through a lot of key concepts that you will be using again in fifth year, whether it's ordinary level or higher level, that you should know already from your junior cert. And as I said, while some of these things may not have come up in your ordinary level junior cert, they will certainly be coming up in the ordinary level leaving cert. So I will make sure to try and distinguish between what things are linked with the ordinary level junior cycle course and the higher level junior cycle course. But as I said, everything I do here you will be expected to know already for a lot of higher level students, and with your new course this year for ordinary level students. If you find today's Saturday session useful, you may be interested in finding out a little bit more about our website. So if you would like to explore the website, please log on to examrevision.ie and you'll see that there's a wide range of junior cycle and leaving certificate subjects on the website. We obviously have maths on the website both for leaving certificate and junior cycle, and you'll be glad to hear that algebra is the free topic that's available for all users. So if you sign up as a free user on our website, you will have access to the entire algebra section on the website, and you'll be able to see lots more Leaving Cert higher level and ordinary level videos which may help you with the topic as you're going through 5th and 6th year. So what we're going to be aiming to get through in today's Saturday session over the next hour or so is to recap all of the key concepts from the Junior Cycle Maths curriculum. And again, I would recommend people to go back over this whenever you're starting algebra. Some of you may be starting it straight away now in 5th year. Some of you might be doing maybe number as your first chapter and then going on to algebra. So this is very much relevant because this literally will permeate all sections of the Leaving Cert curriculum, not just the algebra section. So I think what I always say to my students is whether you're a higher level student or an ordinary level student, you cannot hide from algebra. It's in everything. So this is very much relevant to right now, but it also might be good to rewatch maybe some of the sections of this video when you are engaging in the algebra chapter yourselves in 5th year. Okay, so what I'm going to try and get through is we're going to look at how to simplify algebraic expressions. Again, I'm going to run through a lot of this quite quickly, but just to refresh your memories, we're going to really quickly look at multiplying out brackets. We're going to go back over how to complete long division. We're going to look at some factorizing questions. We're going to look at how to solve algebraic equations. We're going to go and look at how to simplify and solve algebraic fractions, which is a big part of the Leaving Cert course for both ordinary level and higher level. We're going to look at some simultaneous equations, and we're also going to talk about linear inequalities. So we've got lots that we want to get through in the next hour to really get you set up and ready to go for your 5th year ordinary level and higher level maths. So before we move into looking at the content then, just to show you, these are screenshots from the Junior Cycle curriculum. So these are all the areas that you should have completed relating to algebra. Now I haven't taken out some of the functions and some of the pattern stuff, okay? So this is purely just the algebra areas within this strand. And again, I'm not going to go through it all. I've summarised it on the previous slide, but just to show you that nearly all of this is relevant to both higher level and ordinary level students from the junior cycle, and it's only these sections that are in bold that link with the higher level students for junior cycle. So again, it's just to show you that a lot of the stuff I'm going to go through today is very much relevant to both ordinary level and higher level junior cycle students, and then more so into the Leaving Cert as well. So we're going to start off talking about simplifying expressions. So the first thing you need to remember in algebra is that you're going to hear the word simplify a lot and you're going to hear the word solve a lot. And you're also going to see the word expression, and you're also going to see the word equation. So when we're talking about an expression, it's a group of terms, and we can't do anything with these terms other than simplify them. And the reason is because there's no equal sign. So for example, you might have an expression as follows. You might have, let's say, 5a plus 2b minus 3b plus 2a. And we're going to have to collect up the like terms. So what you might remember from your junior cert is you're going to maybe underline or circle what they have in common. So we can see that this term and this term are similar, and we also have our b's. So we have our 2b and our minus 3b. And if we collect those up, then we've got our 5a plus 2a, which gives me 7a, and we have our plus 2b minus 3b, which gives me minus b. Now, another little thing just to remember from your junior cycle is when we're collecting up like terms, you always look for the operation that's in front of the term. So for example, if we look at the yellow underlined parts where we have our plus 2b and our minus 3b, if you're kind of getting confused and saying to yourself, is that going to be like 5b or minus 5b or minus b? What we do is we look at the fact that this is plus 2b and this is minus 3b. So it's almost like saying 2 minus 3, which we know gives us minus 1. And that is the minus 1 there. We just don't bother writing the 1 because in algebra we just leave it as the variable when it's 1 or minus 1 for that matter. But again, just use that to help you. And then for the other one, if we look to our green parts, we can see it was 5a plus 2a. Now you might be saying, but there's nothing in front of the 5, but you know, if it's a positive starting off an expression, they won't bother writing the plus, but that is the same as plus 5 plus 2, which obviously gives us plus 7. Okay, so let's have a look at another expression, and again we're being asked to simplify this expression. So we're going to collect up the like terms as we discussed already. Now in algebra, again, when we're thinking about like terms, you're used to probably seeing a lot of examples where there's like a's and b's or x's and y's, but we also need to remember that sometimes our variables might have little numbers up on their shoulders, and they're called indices. And while these all have the same letter, okay, so they all have the same variable, they all have x's, they're not the same, because we can see some of them are x squareds, okay, and some of them are just x's. Okay, and obviously more than one x, but just the letter that's there, the variable that's there is the letter x. So what we need to always be thinking about is if you're kind of stuck or if you're unsure about whether they're like terms or not, think about if I said to you, okay, I have the number 3, okay, but we know that the number 3 squared is certainly not the same as 3. And that's the exact same as us saying x and x squared. They're not the same because obviously they're not going to give you the same numerical answer. So another quick thing to remember then is that unless variables have the same number on their shoulders, they're not considered to be like terms. So in this question we can see we have 3x squared plus x squared plus 2x squared. So they're all x squareds, so we can collect them up. So that's going to be 3 plus 1 plus 2. So that's going to give me 6x squared. And then in our green, we can see we have minus 4x minus x. So again, that's the same as like saying minus 4 minus 1. So that's going to give us minus 5x. Okay, the next thing we're going to revise is multiplying out brackets. So again, from your junior cycle, you should remember this as something where sometimes you might see it written as expand the brackets or get rid of the brackets, but again, we're just multiplying them out. So you need to remember that if there's a number or a letter or a variable, as we say, outside of a bracket, it means that we multiply that by everything inside the bracket. So when I do this with my own classes, I always say to them to draw their arrows. We're going to take the number 2 on the outside, and that has to multiply by all of the terms inside the bracket. So it's going to be 2 multiplied by x squared, and that gives us 2x squared, and 2 multiplied by 3x. So we do the 2 by the 3, and that gives us 6x altogether. So that's our first bracket multiplied out. Moving on to our second one. This one is a tiny bit more tricky because we have a number and a variable outside, okay? So again, we're going to use our arrows to draw into our bracket, and we have 4y multiplied by x, so that gives me 4xy. We have 4y multiplied by minus 3, so that gives me minus 12y. So again there I had to do a plus by a minus, which gives me a minus. Then we did the 3 by the 4, which gives me 12, and then the y by nothing else, so it just stays as y. And finally we have 4y multiplied by 2y. So we'll do the numbers first. So we do plus 4 by plus 2, which gives me 8, and y multiplied by y gives me y squared. Now what you do before you finish off this question is just double check that there's no like terms here. You might be tempted to add the 12y or the minus 12y and the plus 8y squared, but remember, because there's a square there, they're not the same, okay? They're not like terms, therefore that's your final answer because you can't do anything else. Now the final example we're going to look at for multiplying out brackets is we're going to have a look at this double brackets question. Okay, now again with double brackets there's a few different ways of teaching this. I'm just going to show you the way that I would do most often with my classes. You may have done it out as a box as well, and you can do it that way, no problem. But because it's a double bracket, we need to make sure that everything is multiplied by everything in the two brackets. So I do it again with my arrows. I'm going to say the first by the first, the first by the second by the first, and the second by the second. Okay, so we're going to multiply that out. So we're going to do x multiplied by x, which gives me x squared. Then we'll do x multiplied by minus 3, which gives me minus 3x. Then we'll do 2 multiplied by x, which gives me 2x. And 2 by minus 3, so a plus by a minus gives me a minus. 2 by 3 gives me 6. And again, we need to check that there's no like terms. But this time we can see we have a minus 3x and a plus 2x, which are like terms. So we need to add those together before we finish the question. So we'll write down our x squared, and then we have minus 3x plus 2x. Again, remember, they're not multiplying now, they're just adding together. So that's going to give me minus x minus 6. And that's our final answer there, okay? Again, take note that we did not add the x squared on because x squared and x are not like terms. The next thing we're going to look at from the Junior Cycle Algebra topic is long division. Now, as I said, I'm going to kind of make it out clear as we're going along what things relate with the ordinary level and the higher level curriculum. So anyone that did higher level, you guys will need to be able to do all of this. Anyone who did ordinary level for your junior cert, just to be aware that in your junior cycle exam, you guys were expected to be able to complete long division with just quadratics. Okay, so this first example that we're going to do, you guys should have been able to do at ordinary level, and then the second example I'm going to do in a second, you would not have been expected to be able to do for your junior cert. So you could skip over this, or you could have a look at it and see can you work it out, because it's very, very similar the way I'm going to show both methods. Obviously there's more than one way of doing these, but I just want to show you the long division method for now. So we want to divide x plus 6 into this quadratic, okay? So as I said, this is on the ordinary level junior cycle curriculum. So again, the way I'm going to show you is using our long division method. You can use the box method for this as well. So if you're used to doing it the box method, you should be able to just test out your method and you should get the same answer as me. So the way that we do it to start off with is we take the term on the outside, which is x, and we divide it into the term on the inside. So we say, how many times does x go into 8x squared? Or another way of saying it is, what do I multiply x by to get 8x squared? And that is going to be 8x. The next thing you do is you take that term and you multiply it by the two outside terms. So 8x multiplied by x gives me 8x squared, and that should always be the same as what's above it. And then 8x multiplied by 6 gives me 48x. The next thing we do is we change the signs of both of those terms that we've just written down. So that goes to a minus and that goes to a minus. And the next thing we do, I've kind of just made this up, but I call it column addition. So we're going to add, obviously going downwards. So 8x squared minus 8x squared is going to go to 0, and that should always go to 0 if you've done that properly. And then we have 45x minus 48x. So that's going to give me minus 3x. The next thing we're going to do is bring down the next available term. So in this case, we have our minus 18. And we're going to start the whole process again. So we're dealing with the x again up on the outside, and we're dealing with the minus 3x. So we say to ourselves, what do we multiply x by to get minus 3x? And the answer is minus 3. So I'll write that up on the top again, and I'm going to multiply that, as we've done already, by the two terms on the outside. So that's going to give me minus 3x and minus 18. Again, we go and change both of those signs. That's going to change to a plus. That's going to change to a plus. We do column addition. Minus 3x plus 3x goes to 0. Minus 18 plus 18 goes to 0. And we're done. We know we've done it properly because there's no remainder. So this is our answer here. Okay, so the answer to this question, when we divide our quadratic by a linear, we get 8x minus 3. Now, as I said to you a minute ago, there was lots of ways to answer that question. You could have actually just factorized the quadratic and you would have seen that 8x minus 3 was the other factor. But I just wanted to show you the long division way, which ordinary level students are expected to be able to do from their junior cert, and obviously higher level students as well. So the next part of this example that I'm going to go through is going to be relevant to anyone who's done higher level for their junior cert. So in this question, which is taken from the Junior Cycle papers, one of the sample papers, we're being asked to show that 2y plus 3 is a factor of 2y cubed minus 9y squared minus 28y minus 15. And as I said, this is from the higher level Junior Cycle paper. So we're going to set it up the exact same way. So we're going to divide in our 2y plus 3 is dividing into 2y cubed minus 9y squared minus 28y minus 15. So step 1 is we need to ask ourselves, what do I multiply 2y by to get 2y cubed? And the answer is going to be y squared. As I showed you before, we're going to take that and multiply it by the terms on the outside. So that gives me 2y cubed plus 3y squared. We're going to change the signs and we're going to do our column addition, and that's going to give me minus 9y squared minus 3y squared, and that gives me minus 12y squared. We're then going to take down our next available term. So this time, because it's a quadratic, we will have to do this one more time. Start the process again. What do I multiply 2y by to get minus 12y squared? And the answer is going to be minus 6y. Multiply that by the two terms on the outside again, and that's going to give me minus 12y squared minus 18y. And again, change my signs, complete my column addition, and that is going to give me minus 28y plus 18y. So that's going to give us an answer of minus 10y. And we bring down our next available term, which is minus 15. And we start it again. So what do I multiply 2y by to get minus 10y? The answer is going to be minus 5. So that's going to give me minus 10y minus 15. Change both the signs. Column addition. You see they both go to 0, which is good because it means we don't have any remainders. So we're going to take what's up here and we're going to show, this is obviously our final answer here, let's say, but we need to go back to our question, okay? Because think about, we were being asked to show that 2y plus 3 is a factor. So because we were able to divide that in and we have no remainder, that means that yes, 2y plus 3 is in fact a factor of that cubic. We will go on and do more work on this in the higher and ordinary level Leaving Cert course, but it's really important to remember that if something is a factor, it should divide in with a remainder of 0. If, let's say for argument's sake, we were being asked to work out the other factors, you would then go and take this quadratic and factorize it to get the two other factors, because remember, this is a cubic, which means that it has 3 factors. But again, we'll talk about more of that in the Leaving Cert Ordinary Level and Higher Level course, which will build on this knowledge that we are talking about today. So the next thing I want to talk to you about is factorizing. Now, definitely as a higher level and ordinary level junior cycle teacher, I would say this is definitely one that students always ask me to go back over. And I suppose it's important when you're factorizing to just think about what the process is actually doing. So when you're asked to factorize, you're basically simplifying an expression in, a different way. You're kind of trying to bring it back. So if you have, let's say, a quadratic and you're being asked to factorize it, you're being asked to split it up into its other factors, take out what's in common. You're being asked to bring a term or a number to the front of the bracket because it's in common with everything else. So there's 4 different types of factorizing that you should have known from your junior cycle, okay? And I want to do it out like this so you can kind of see them all together. So the first one that you should be familiar with is where you take out a common factor. So for example, it could be something like 2x plus 4xy minus, let's say, 8x squared. And you're being asked to factorize this. So what you would need to do is you would need to look at the expression and you would need to take out what's in common between all of the terms. So we can start off with the numbers. So what number divides into 2, 4, and minus 8, okay? And the number that would divide into all of them would be the number 2. And then you say to yourself, okay, we've got the number part done, what about the variable? So if we look at x, xy, and x squared, what variable is in common between all of them? And the answer would be x, not x squared, because x squared isn't in all of them. Then you would set up your bracket. And what I always say to my students is you need to say to yourself, similar to, I suppose, what we did in the long division, what do you multiply this by to get this? So what do I multiply 2x by to get 2x? Now sometimes that nearly seems like a trick question, but you have to put something down in the bracket. So 2x multiplied by what gives you 2x? It's the number 1. Then we say 2x multiplied by what gives me 4xy. So 2 by 2 gives me 4, and x by y gives me xy. And finally, what do I multiply 2x by to get minus 8x squared? So again, 2 by what gives me minus 8? It's going to be minus 4. And x by what gives me x squared? It's going to be x. So that would be your answer for that first question. If you were being asked to factorize, you would take out what's in common between all of the terms. And we generally would call that first type of factorizing common factors. Okay, you're taking out what's in common between all of them. The second one that you should be familiar with is something that I would call with my students gang of 4. Some of you might just know it as grouping. So for example, if we had something like this, wy minus y minus 1 plus w. So what we would do is we need to, because I suppose the first thing you're going to look at is see, is this a common factor one, like part 1. But what you're going to notice is they don't all have w's in common, they don't all have y's in common, so it's not going to work like we did in part 1. So what we do is we group them together. So we look and we see that these 2 terms have the letter y in common, and we can group these ones together and just say they have the number 1 in common. So that's how we're going to start it. So we're going to come down to the next line and we're going to take out what's in common between just the first 2 terms. Now it doesn't always have to be the first 2 terms. You might remember from your junior cert that you actually go and like scramble them all up if you need to, but these have the variable y in common. So we'll take y to the outside and we say, what do I multiply y by to get wy? And it's going to be w. And what do I multiply y by to get minus y? And that's going to be minus 1. And we go and do the exact same thing to our second set of variables. But what we're going to notice here is that there is like nothing in common between the other 2. So what you could do to start off with is say, okay, I know that there's a minus 1 and a w, which means that the only thing that they have in common is the number 1. And we need to basically work out whether it's going to be a plus 1 or a minus 1. So if we think about it to begin with, then if I put a plus out here and we say, okay, what do I multiply plus 1 by to get minus 1? the answer would be minus 1. And what do I multiply 1 by to get w? It's going to be w plus w. And what you always need to check for a gang of 4 question or a grouping question, if you've done it properly, these two brackets should always be the same. Even though they're the opposite order, it doesn't matter. They both have a w and they both have a minus 1, which means you've done this properly. And the final thing you have to do with the gang of 4 question or a grouping question is you take the two terms that are on the outside of the brackets, so this one here and this one here, and you put it into the first bracket, so y plus 1. And then you take the other bracket and you just write that out once. So I'll do w minus 1. It does not matter which one you pick because they both mean the same thing. So we can see here the final answer for this question is y plus 1 multiplied by w minus 1. And that is a gang of 4 question. The way you're going to spot a gang of 4 question or a grouping question is that it's going to have 4 terms from the junior cycle, and they won't all have something in common. If they all had something in common, then you could have done this method. But because they don't, you're going to use your gang of 4 method. Okay, moving on to type number 3. This one is a quadratic. Now, it's no exaggeration to say that this is an absolute must that you need to be able to do for your Leaving certificate. It's been a running joke in my Leaving Cert classes over the years that basically every question ends up as a quadratic. Now, it's not quite that extreme, but I can guarantee you in a wide range of chapters you are going to see quadratics coming up. Okay, so it's very, very important that you become comfortable with factorizing quadratics. So we're going to look at a question now from the Junior Cert again, and this one is going to be n squared minus 11n plus 18. Now, while this question is from the higher level junior cycle sample papers, this is also a requirement for the ordinary level. So again, any ordinary level students tuning in from junior cycle, you should have been able to do this for your junior cycle as well. And again, you will have time to practice it in Leaving Cert, but you are expected to be able to understand how to work it. The only difference between higher level and ordinary level is higher level students also sometimes had numbers in front of the like x squared or the n squared variable, whereas ordinary level students didn't. That's the only difference between those. So again, lots of different ways of factorizing quadratics, but generally speaking, what I would have asked my students to do is look at the number 18 first of all. So the number that does not have another variable beside it, so the coefficient, the constant, and 18, so plus 18. So what you need to do is you need to say to yourself, what two numbers multiply to give you plus 18? So you're going to basically look at the factors, okay, that would multiply to give you 18. So one would be 2 multiplied by 9, another would be 1 by 18, another one would be 3 by 6. And what we basically need to start doing then is start thinking of what combination of those is going to give me the minus 11. So what we also need to be aware of is that that's a plus 18. So the two numbers both need to be plus, so like plus 2 multiplied by plus 9, or they could both be minus, because minus 2 by minus 9 also gives me plus 18. Plus 18. So that's important. So when we're looking here that's a minus, don't be panicked by that, because we know that two minuses, when they multiply by each other, actually give me a plus. So that means that both of those are going to have to be minuses. So if we look, I think it's quite obvious to see that the only one of these combinations, when they're added together, that gives me minus 11 would be minus 2 and minus 9. So what we're going to do next is we're going to make this then into those two numbers. So we're going to change minus 11n into minus 2n minus 9n. Because remember, that means the exact same thing. Minus 2n minus 9n can be simplified to give me minus 11n. And then we're just going to write down our plus 18 at the end. And what we're going to do next, just like we did in our gang of 4, is we're going to take the first two terms and we're going to factorize those. And we're going to take the next two terms and factorize them. So what's in common between n squared and minus 2n? Hopefully we can see it's n. So then that's going to give me n minus 2. And what's in common between minus 9n and plus 18? And hopefully we can see that it is our 9 or our minus 9. Okay, now what I normally do is I write my 9 down to begin with, and I look at what's inside. So we can see in this bracket here that this is a positive. So I know then if I put n in here, that's going to then give me a positive if I put my minus on the outside. And similarly then on the inside I have plus 18. So what do I multiply minus 9 by to get plus 18? It's going to be minus 2. And happy days, we can see that these two brackets are the same, which is exactly what we need. So we're going to then take this term and this term, and we're going to write it down in one bracket, so n minus 9, and then our other bracket we write down n minus 2, and that's our final answer. So that is how you factorize a quadratic, and that's our third type of factorizing. And how you're going to spot a quadratic is there is generally going to be 3 terms. Sometimes this term here could be 0, but you know the general ones that you're used to seeing from your junior cycle would be 3 terms, where one of them is squared, one of them is linear, and one of them then is just a constant number by itself. And then the final type of factorizing that you guys need to be able to do from your junior cert is the difference of 2 squares. Okay, and again, looking at your junior cycle curriculum, you are expected in ordinary level to be able to do this as well, just without the coefficients in front of the variables. So I'm going to take you through a quick example now, or 2 examples. So the ordinary level version would be something like this: a squared minus b squared. And this is called the difference of 2 squares because we have 2 square numbers and we have a minus between them. And the way that you would have learnt to complete the difference of 2 squares is both of them should have squares on their shoulders, which they do. So that's step 1. That's already done for us. And basically what you do is you split them between the 2 brackets. So the a squared gets split up into a and a, and the b squared gets split up into b and b. And then you put 1 plus in one bracket and 1 minus in the other bracket. Now, I'm obviously not going into the nitty gritty of why we do this. That's in all my junior cert videos on ExamRevision. But the reason why this works is basically because one is a plus and one is a minus. It cancels out the a-b coefficients, and that's why we're just left with the a squared and the b squared. So all ordinary level students should have been able to do that, and obviously higher level students. And then a higher level example, which I'm taking from the junior cycle exam, is a squared minus 16n squared. So the only thing that makes this one a little bit harder is we've got a coefficient there in front of the n squared. So step 1, as I said, is we make everything have a squared on its shoulder. So the a one is done for us already, but then in order to put the 16 inside, I need that to have a 2 on its shoulder, so it needs to be squared. So you can't just write 16 in here, because then that would make the number massive when you square it. So what number squared gives me 16? Or if the square root is 16, which is 4. And now we go and do the technique I just taught you. Okay, so you're setting up your double brackets. We put a in here, a here. We put 4n here and 4n here. And we have a plus and a minus, and you're done. Okay, so that is how you factorize the difference of 2 squares. Now, I know that took a little bit of time to go through, but that is definitely an area of the junior cycle curriculum that a lot of students would still struggle with going into their Leaving Cert. So if that is an issue that you're kind of thinking, yeah, I'm still not 100% confident on that, I would definitely recommend that you spend a bit of time yourself going back through those topics on factorizing, because it does come up quite frequently in your Leaving Cert course. So the next thing we're moving on to is algebraic equations. So again, as I mentioned earlier, what's really important to note now at this stage is we're looking at the word equation now rather than an expression. And if this comes up in your junior cycle or your Leaving Certificate, the word that you're going to see written at the top of the page is solve. So we're being asked to solve these equations. And the definition of an equation, it is a group of terms which are equals to each other represented by the equal sign. So you're going to have a group of terms on the left, a group of terms on the right, and there's an equal between them, which obviously means that they are equals to each other, and you can then go and solve the value for the variable in question. So the variable again is your like the letter. So in this case you can see we have 5x minus 2 is equals to 13. We're being asked to solve this to figure out what the variable is equals to. So basically we're trying to figure out the answer for x. So again, back in junior cycle, the way that I would always explain this is we're trying to get x by itself, we're trying to solve for x, so therefore we need to get rid of or move the stuff that surrounds the x on the left hand side. So we basically have two things on the left hand side that we need to get rid of. We need to get rid of the 5 that's stuck onto the x, and we need to get rid of the minus 2 that's subtracting from the 5x. So you always start with the things that are not stuck onto the x, because remember that means that it's multiplying, or it could be that it's dividing by the x. You always leave them until the last step. So we're going to get rid of the minus 2 first of all. So in order to get rid of it or to move it to the other side, we need to keep our equation balanced, because right now it's a balanced equation, so we can't upset that. So to get rid of minus 2, we think, well, how would you get rid of minus 2? And hopefully we know you would use an inverse operation, which means that we would plus 2, because minus 2 and plus 2 go to 0. But you can't do that to the left-hand side of the equation without upsetting the right-hand side, so therefore you do it to the other side as well. Okay, so the rule with equations is what you do to the one side, you do to the other. So they're going to go to 0, so I'm going to be left with 5x is equals to 15. And then we need to get rid of the 5 that's stuck onto the x. Remember that means it's multiplying. So what's the inverse of multiplication? It's division. So we're going to divide both sides by 5. And that means a 5 divided by 5 gives me 1, so you're left with 1x is equals to 15 divided by 5, which gives me 3. And that's your final answer. And you can always do a check and sub it back in. So you do 5 bracket 3 minus 2 is equals to 13. So that's 15 minus 2 is equals to 13. So 13 is equals to 13. So that's your first one. The next one then that we're going to look at is just a tiny bit trickier, because the x's are on both sides of the equal sign. So we need to sort that out first. So we have the 3x here and we have the 5x here. So basically I need to get those together on one side, and then I have my plus 2 here and my minus 10 here. So I'll get those together on the other side. So what I'll do to start off with is I'm going to move my 5x over to the left hand side. So what I need to think about again is, what's the inverse of 5x? Well, right now, if you imagine there's like an invisible plus there. So the opposite of plus 5x is minus 5x. And therefore, I need to do it on the left-hand side as well. So I'm going to be left with 3x minus 5x, which gives me minus 2x, plus 2. I'll sort those out in a second. That goes to 0, and I'm left with minus 10. Now I'm back to what we were doing up in this example. So I need to get rid of the minus 2 that's stuck in front of the x, which means it's multiplying it, and I need to get rid of the plus 2. We always get rid of the things that are not stuck to the x, first of all. So we're going to get rid of the plus 2. What's the opposite of plus 2, or the inverse? Minus 2. So we minus 2 from both sides. I'm left with minus 2x is equals to minus 12. And then we need to get rid of the minus 2 that's multiplying by the x. So the opposite of multiplying by the x is dividing. So we're going to divide both sides by minus 2, and therefore we get an answer that x is equals to 6. And we can do another check by adding that into our question. So 3 bracket 6 plus 2 should be equals to 5 bracket 6 minus 10. And if we test that out, then that's going to be 20 is equals to 30 minus 10, which is 20. So what we looked at in the last two examples were examples of linear equations. You also need to be familiar with quadratic equations in your Leaving Cert. And again, this is relevant to students who've done ordinary level for both who've done ordinary level in their Junior Cert and higher level in their Junior Cert. You need to be able to solve a quadratic equation. And again, this is something that comes up all the time on the Leaving Cert curriculum. So we have two ways to solve quadratic equations. The first is we can use the factorizing method and then solve each of the factors. And then the second way is we can use the minus b formula. So I'm going to show you both methods here. And as I said, this is on the ordinary level and the higher level leaving or junior cert. So if we start off using the factorizing method, now the one thing you need to be careful of with using the factorizing method is just read the question and make sure they haven't said that you need to round your answer to 1 or 2 decimal places. If they've said that, you have to use the second option because it will be very difficult to do it with non-whole numbers. Okay, so if we are given this quadratic, so we've got x squared plus 6x minus 16, we're going to try it using the factorizing method. So we're going to start off by factorizing this quadratic like I showed you earlier on. So it's going to be x and x, and if you remember, we're going to go to minus 16, and we're going to think about two numbers that multiply to give us minus 16. So 8 and 2, 16 and 1, 4 and 4, and then which one of those can we use to create the plus 6x? So that's going to be the plus 8 and the minus 2. Remember, because it's minus 16, one has to be a plus and one has to be a minus. I'm just going to skip a step here and just put it straight into the brackets, but you guys can obviously make your 6x out of the 8 and the minus 2. So that's going to be plus 8 and minus 2. Normally in factorizing you would just stop there because it wouldn't be equals to 0, but now we're going to take both of those factors and let them equals to 0. And we're going to solve them. So we're going to get x by itself. So we're going to minus 8 from both sides, so we get x is equals to minus 8, or we're going to plus 2 from each side, x is equals to 2. So there are your two answers, and if you wrote those down and you did that method for this particular question, you would get full marks. However, there's another method that you can also use, and again, in these questions, if they ask you to solve a quadratic, but they say to round it to a few decimal places, you know you have to use this method. So it's our minus b formula, which is x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. You don't need to know it off by heart. It's actually on page 20 of your formula tables. You can see there's three letters at play there. There's a, b and c. So a is always the number in front of the x squared. B is always the number in front of the x, including its sign, and the same with obviously the x squared one. And c is always the number by itself. So in this particular question, a is 1, b is plus 6, and c is minus 16. So we're going to sub each of those into our formula. So it's going to be x is equals to minus 6 plus or minus the square root of 6 squared minus 4 times 1 times minus 16 all over 2 times 1. And when you pop that into your calculator, you're going to get the same answers, that x is equals to 2 or x is equals to minus 8. So again, two different methods for solving quadratic equations. So both ordinary level and higher level junior cycle students would also have worked with algebraic fractions, and again this is something that does feature a lot in the Leaving Cert questions at both ordinary level and higher level. So we're going to have a look at this question. I've taken it from the ordinary level junior cert, so everyone, both higher level and ordinary level students, should be able to give this a good go. So in the exam question we were asked to express this collection of terms as a single fraction and give your answer in its simplest form. So what we want to do here, like we would have done back in first year when we were just dealing with numbers, we want to write this as a single fraction, and the way we do that is we always look for the common denominator. So what you're going to do is you're going to look at the numbers that are in the denominator section of your fractions, which is the numbers underneath. So we need to look at the 3 and the 2 and say to ourselves, okay, what number will both of those numbers divide into? And I'm sure a lot of you are saying to me, it's number 6, okay, because both 3 and 2 will divide into the number 6. So 6 is our common denominator. And what we need to do is, like with any fraction question that you do in primary school, what you do to the bottom, you must do to the top. So what we say to ourselves is, what did we multiply the 3 by to make it into the number 6? We multiplied it by 2. So what you do to the bottom, you must do to the top. So we're going to do 2 bracket 2x plus 1. And then similarly, what do we multiply 2 by to get the 6? We multiply it by 3. Whatever the sign is here, we write that down. So it's going to be plus 3 bracket, and then what was it on the top of the fraction originally. And now we're back to pretty straightforward maths, hopefully, just using some of the skills we've already looked at. We're going to multiply out these brackets and then we'll collect up the like terms. So that's going to give me 4x plus 2 plus 9x minus 15 all over 6. And then we're going to add the x's together. So that's going to give me 13x, and we're going to add the numbers together, which gives me minus 13, and that's all over 6. And that's your final answer. That is your fraction in its simplest form. So similar to simplifying algebraic fractions, we also need to know how to solve them. So what we're going to notice in this particular question is we have an equal sign, whereas in the last question we were just asked to write it as a single fraction. So that was an expression, whereas this time we're dealing with an equation. You'll be glad to hear though that the method that you're going to use to solve this is quite similar to the previous method for the fraction part. So what I would generally recommend is that we write the fractions on the left or the right as one fraction, and then we go and solve the entire equation. So I'm going to start off by taking the left hand side in this particular example, and we're going to write this as one fraction. Now there is more than one way of doing this, but this is just the way that I like to teach. So we're going to do exactly like we did in the last question, where we're going to create this as we're going to turn this into one fraction. So we look for a common denominator between 3 and 5. And the number that they will both divide into is 15, the lowest one that they'll both divide into. And again, what we do to the bottom, we must do to the top. So I've multiplied 3 by 5, so therefore I multiply the top by 5. There's a minus here this time, so I'm going to write down minus. We multiply the 5 by 3, so we'll do that to the top as well. And then for the moment, we're just going to leave it equals to whatever was up there. So it's equals to 3. We're going to forget about that, kind of just keep writing it down, keep your equal sign coming down underneath, but we'll come back to that in a few minutes. Like we did in the last example, we're going to take the numbers in front of the brackets and multiply them. So that is going to give me 5x plus 15 minus 3x plus 12 all over 15 is equals to 3. We're then going to need to get rid of the fraction on the bottom and also tidy up the top. So if I collect up the like terms, that's going to be 5x minus 3x, which gives me 2x, and 15 plus 12, which gives me 27. I'm also going to get rid of this divided by 15. So the opposite of dividing by 15 is multiplying by 15. So on the left hand side, they're inverses of each other, so that goes to 1, and 3 by 15 is going to give me 45. Now we want to get rid of the 27, so we're going to minus 27 from both sides. So we're going to be left with 2x is equals to 18, and then I'm going to divide both sides by 2. So therefore, x is equals to 9. And if you want to check your answer, I'm not going to do it here, but you can sub it back into the original question, and the left hand side, when you pop that into your calculator, should give you the answer of 3. Next up on our list is simultaneous equations. So simultaneous equations are where we're trying to work out the value of two variables. So in the last couple of examples where we've looked at equations, we've been solving them for one variable, but in this case we're trying to work out the value of x and y. And hence where our simultaneous equations come from. So when we're dealing with simultaneous equations, there's a few kind of, I suppose, slightly different methods that we need to kind of go through in order to get our final answers, because we want to find out where in these two equations what value of x is the same in both of them and the value of y that's also the same. If you're relating this with a graph on your coordinate grid, you will hopefully remember that when you solve simultaneous equations, that your x and y value will represent where the two lines intersect each other, because that is where their x and y value is the same. So we're going to start off then by looking at this question. Again, this is relevant to ordinary level and higher level junior certificate students going into their Leaving Cert. So what we need to do in simultaneous equations, the method that I use most of the time, is the elimination method. And the elimination method works by getting rid of either the x or the y or one of the variables. And in order to do that, they need to be inverses of each other. So one needs to be a plus, one needs to be a minus, and they both need to have the same number. So for example, if one of them was plus 2x and the other was minus 2x, that would go to 0. Or if it was plus 3y and minus 3y, they would go to 0. So that's kind of what we need to come up with. So we can choose to get rid of either the x's or the y's. It makes absolutely no difference. In this question, I'm going to choose to get rid of the y's. So that means that I need to figure out what would make those add together to give me 0. And as I said, if we could get a 3 in there, that would do it for us, because it's plus 3y minus 3y, which would go to 0. But we can't just magically pop a 3 in there. We have to do it to the entire equation in order for the equation to stay balanced. So what we're going to do is we multiply everything by 3. Okay, it's not adding 3, it's multiplying, because remember the 3 needs to be stuck onto the x, which means that it's timesing by it. So we're going to multiply everything by 3 first of all. So that's going to give me 6x plus 3y is equals to 15. And I don't have to do anything to the second equation because I already have my minus 3y there. So it's x minus 3y is equals to minus 8. Now we're going to do column addition. So again, I'm going to be adding going downwards. So we're going to start off with 6x plus x, which gives me 7x. The plus 3y and the minus 3y go to 0, and we have 15 plus minus 8, which is going to give me an answer of 7. Then we're going to divide both sides by 7. So we're going to divide the left-hand side by 7 and the right-hand side by 7, and we get an answer that x is equals to 1. But we're not finished yet, because remember we need a value for x and a value for y. So whatever you get for x or y, you're going to substitute it back into one of your equations. It doesn't matter which one you pick. I'm just going to go with this one here, but if you pick the other one, you'll still get the same answer. So I'm going to sub it into x minus 3y is equals to minus 8. So that's going to give me 1 minus 3y is equals to minus 8. I'm going to get rid of the 1 first of all. Remember, we always get rid of the things that isn't multiplying or dividing by the y. So minus 1 minus 1. So that means minus 3y is equals to minus 9. We're going to divide both sides by minus 3. And therefore y is equals to 3. So the last thing that I want to cover today is linked with linear inequalities. And again, this is relevant to both ordinary level and higher level junior cert students going into the 5th year. So when you're dealing with inequalities, you need to be familiar with your number systems. And this is definitely something that you will revise when you start 5th year, I'm sure. So there's lots of different number systems that you'll be looking at, but the ones that are most relevant to our number systems, or to our inequalities chapter, is n, which stands for our natural numbers, z, which stands for our integers, and or, which stands for real numbers. So natural numbers are numbers that are whole numbers, positive whole numbers, that start from the number 1. So basically 1, 2, 3, 4 to infinity. Z stands for integers, and integers are positive and negative whole numbers and 0. So that's like minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, out to infinity in the negative and in the positive. And then or stands for the real numbers. So they're all the combination of all the rational and irrational numbers. And they would have been the only kind of the main umbrella term that you would have used in your junior cycle. So you need to be able to plot inequalities on the number line. So that's what we're going to look at first of all, before we look at solving them. So in this first example, and this is taken from ordinary level junior cycle papers, and again this could be definitely something that higher level students would have been working with as well. So it says x is less than 3 and x is an element of n. So what you need to remember, if you're being asked to plot n or z on the number line, one of the tricks that I would have always said in junior cycle is we draw noses. Okay, so n or z means noses. So basically that's like you draw little dots. Okay, because they only stand for whole numbers. So if x is less than 3, it can't be the number 3. So it's the next whole number that's less than 3, which would be the number 2. And it could also be the number 1. But because this is an element of n, we need to remember that n only starts from 1. So even though you might be kind of thinking, oh, should I shade that in and that in? No, that's incorrect, because it's an element of n, which means the first possible answer could be is the number 1. So therefore, there are your two answers. Moving on then to the second example, which is x is less than 3 again, but this time it's an element of z. And remember, we still draw noses or dots, but z is both positive and negative whole numbers and 0. So we start with the next whole number that's less than 3, which would be 2, and then 1, but this time we can go to 0, we can go to -1, we can go to -2, and it will continue out to the left-hand side to infinity. So what you do is you draw yourself a little arrow on your number line to show that it's going out to the left-hand side. And then our final one to look at is that x is less than 3 again, but this time it's an element of or. So if you see or, it's a rational number, or sorry, a real number I should say, but in this case we don't draw noses. Because it's or, you're going to draw a road. Now, the reason why we draw a road, which is basically a continuous line, is because they're not just whole numbers anymore. There are also all the other little numbers in between, like the fractions and the decimals and stuff like that. So for example, x is less than 3. Well, it could be 2.99999, or it could be 1.5786. It could be any of those numbers because it's a real number, so it's all the rationals and irrational numbers. So what we do, as I said, is we draw a road. You always start the road at whatever this number is. So it's 3, so I'm going to put a circle. Now, if there's nothing underneath the inequality, you leave it as an open circle, so that's correct. But let's just say for argument's sake, there was a line underneath it, you would colour in the circle. So if it's less than or greater than by itself, it's an open circle. But if it's less than or greater than and equals to, you shade in your circle. So that's the first step. And then we say, right, x is less than 3, which means that it's going all the way out this way to the left. And again, we draw our arrow to show that it keeps going out to the left. So moving on then to this example, we're going to be looking at how to solve linear inequalities. So we're going to be using all the same tricks as before, except this time we're going to actually have to solve it and get an answer. So what you're going to be doing here is you're going to nearly pretend as if the inequality is an equal sign. But we do have to be a little bit careful sometimes where we are working with minuses when you're multiplying across by a minus or dividing by a minus. So we'll come to that in a few minutes. So as I said, we're going to treat this like a normal equation, and we're going to be trying to get x by itself. And again, you're going to try and use the similar tricks that you would have used previously to get x by itself. So in this particular question, we have the 2 and we've got the -7. So we're going to get rid of the -7 by plussing 7 to both sides. So I'm left with 2x is less than or equals to 8. Then we want to get rid of the 2, so we're going to divide both sides by 2. So we get x is less than or equals to 4. In this question, we're also asked to represent this on a number line. So we need to think about the fact that x is less than or equals to 4, and we also need to think about the fact that we're told that x is an element of z. So again, you're trying to go back to the knowledge that you have from your junior cycle. What does that actually represent? And we know that when we see z, that means that we're thinking about noses. So we're dealing with integers, which are whole numbers. So x is less than or equals to 4, and we need to draw noses. So basically we're going to have dots on our number line. So the next available whole number, which is less than or equals to 4, is 4. And we're then going to go to 3, 2, 1, 0, -1, and -2. And then we're going to draw an arrow out to the left-hand side to show that this will continue on to infinity, because it's going to keep going down the negative side. And that is your final answer. So in a lot of these questions, you'll work out the solution and then you'll put it onto the number line. Now, I want to just change this ever so slightly and just pretend that this question was a little bit different and it was -2x is less than or equals to 8. Obviously, it's not, but I'm just making up a new question. We need to be really careful, because when we multiply or divide across by a negative, generally speaking, the equals in an equation stays as the equals. But in this example, we need to think about the inequality. And the inequality is actually going to have to be flipped the other way around, because it's going to change the meaning of the entire equation. So you're going to divide across by -2. And what's going to happen is the inequality is going to change from being less than or equals to greater than or equals to allow for the fact that you have divided by a negative number. The others you just treat the same, so you'll have x is greater than or equals to, and then you'll do 8 divided by -2, which gives me -4. So you can see there, generally speaking, you treat inequalities like you would equations. The only exception to that rule is if you divide or multiply across by a negative number. Thanks so much for watching today's Saturday session, guys. If any of you are interested in looking at any of our plans and subscriptions on the website, we do have a discount code. The discount code is algebra, and that's going to give you 20% off all the subscriptions on the website. So if you are interested, please do use that, and it will expire Sunday night at 11:59 p.m. Thanks a million, guys, and talk to you soon.